Good morning, ma'am. Myself, Maunika. I am from ECE second year. My roll number 244G580407. Subject probability and complex variable. My topic analytic function and CR equations of Z. First of all, introduction. Introduction of analytic function. Analytic function are complex functions that are differentiable in a neighborhood of every point in their domain. They possess the property that the derivatives can be expressed as power sets. In the complex plane, these functions exhibit conformally and meaning they preserve angles between curves. Characteristics of analytic functions. An analytic function is a smooth and continuous, ensuring an abroad change in its values. They are infinitely differentiable, meaning that all orders of derivatives exist within their radius of convergence. The behavior of analytic function is governed by the Taylor series expansion around points in their domain. Introduction of Cauchy-Riemann equation. The Cauchy-Riemann equation are set to partial differential equations essential for determining if function is analytic. They related the real and imaginary of a complex function. Ensure the function is differentiable in the complex sense. If a function satisfies their equation, it is guaranteed to be analytic in the domain where the equation hold. Cauchy's Riemann equations. This is the Cauchy's Riemann equation. These equations must hold in the open region for the function to considerable analytic that point. These Solving these equations can help identify potential analytic function from their real and imaginary components. Implications of analytic function display unique properties such as identity theorem, which states that if two analytic functions agree on set of 2 points with a limit point, they must be identical. They are exhibits the maximum modulus principle, which asserts that non-constant analytic function cannot achieve its maximum modulus inside domain. Additional analytic functions have integral representation, allowing them to be expressed via contour integrals, a power tool in complex analytics. Applications of analytic functions and CR equations. Analytic functions are widely used in physical and engineering, particularly in fluid dynamics and electromagnetic theory. They are solutions to various boundary values problems, and they are essential is conformal mapping, which are used for transforming complex geometrics. Understanding CR equations is crucial theoretical mathematics as they are found for complex analysis and its applications other mathematical field. My problem is show that the function f of z is square root under square root of x modulus xy is not analytic at the origin even through CR equations are satisfied at the point. This is my problem. Solution. Given function f of z under square root of xy. Here u of x is equals to under root of xy modulus xy is v of xy is equals to 0. Dou u by dou x and in u of 0 comma 0. Limitation x extends to 0. U of x minus x comma 0 minus v of 0 minus 0 x minus 0. This is the formula. We substitute the x and y values. U of x and y values, substitute x is equals to 0. Then limitation x extends to 0. 0 minus 0 divided by x is equals to 0. That is the dou u by dou x. Dou u by dou x is 0. Dou u by dou y, let us consider a limitation y extends to 0. Then u of 0 comma y minus v of 0 comma 0 divided by y minus 0. Then the dou u by dou y is equals to 0. Dou v by dou x. Now we find out the dou u by dou x and dou u by dou y. Now dou v by dou x. Now let us consider x extends to 0. Limits x tends to 0. U x comma 0. V minus v 0 comma 0 divided by 0. Then 0. dou u by dou x, limit extends to y is equals to 0, u of 0 comma y minus v of 0 comma 0, then dou u by dou y is equals to 0. Then CR equations are satisfied at the point of 0 comma 0. F of z, limit z tends to z naught, then f of z, f dash of z minus f z naught divided by z naught minus z, then limitation z tends to 0, then f dash of z minus f of 0, then divided by z minus 0. Whenever z is extends to 0, then we substitute z naught is equals to 0. Limit extends to x comma y 0 comma 0, then modulus of xy under root minus 0 divided by x plus iy, y z is equals to x plus I. That's why we substitute z value in that equation. Then limit x tends to 0, root modulus of x into mx divided by x plus I mx. Limit x tends to 0, x into modulus of m within modulus square root. Then it is the final equation is limit x tends to 0, square root of m divided by 1 plus im. Limit depends upon on m. Limit does not exist. F of z is not differentiate at 0 comma 0. F da, f of z is not analytic at the origin. Thank you.